Hello friends, today's question: the xt graph of a particle undergoing simple harmonic motion is shown below. The acceleration of the particle at t is equal to 4 by 3 seconds. So this is a graph of a particle which is going SHM and its amplitude is plus minus 1, and from here we can say the time period is 8. So we already know that for a displacement of x, the equation for the SHM can be written as x equal to a sine omega t. So you can say that the equation for SHM, it can be written as x is equal to a sine of omega t, and from the graph we can write that from graph we have a amplitude of 1 centimeter and time period, that is capital T, is equal to 8 seconds. So therefore we can find out omega. Omega is equal to 2 pi upon t. So this becomes 2 pi upon 8, and we get this as pi by 4 radian per second. Substituting the value of amplitude and omega, let us suppose this is equation 1. So we can say from equation 1 we have x is equal to 1 sine of pi by 4 multiplied by t, and we have to find out the acceleration of the particle as at time t is equal to 4.3 seconds. So in this case we find out the displacement, that is x, at time is equal to 4.3 seconds, and then we can use the relationship that a is equal to minus omega square x. So we can say at t is equal to 4 by 3 seconds, we get x is equal to sine of pi by 4 multiplied by 4 by 3. 4 and 4 cancels out, so we get x is equal to sine of pi by 3, and which is equal to square root of 3 by 2 centimeters. And for acceleration, for acceleration a, we get a is equal to minus omega square multiplied by x. Substituting value of omega square, we get this as omega, we get pi by 4 whole square multiplied by 3 by 2. So this is minus pi square upon 16 multiplied by square root of 3 by 2. So we get the acceleration is equal to minus square root of 3 pi square divided by 32. So this is the acceleration of the particle at time t is equal to 4 by 3 seconds. This is acceleration of particle at t is equal to 4 by 3 seconds. Now we can do the same question in a different way also. We can use that we already know that x is equal to, from equation 1, x is equal to a sine omega t, and if we do it's a single derivative, we get the velocity, equation for the velocity rather, and if we do derivative of second time, a double derivative of x, we get the acceleration. So let's try the second approach. Second method, so we know that x is equal to a sine of omega t, and here we already know that our a is equal to 1, and we calculated that omega is equal to pi by 4. Substituting, we get x is equal to sine of pi by 4t. So from here we can write that velocity v is equal to dx by dt, and this gives us pi by 4 cos of pi by 4t, and acceleration a will be equal to dv by dt, and this will be coming as minus pi by 4 whole square sine of pi by 4 t. So we are going to find out acceleration at time t is equal to 4 by 3 seconds. So at time t is equal to 4 by 3 seconds, we get acceleration is equal to minus, this becomes pi square upon 16 sine of pi by 4 multiplied by 4 by 3, and 4 and 4 cancels out, so this becomes minus pi square upon 16 sine of pi by 3, and sine of pi by 3 is root 3 by 2. So we get acceleration is equal to square root 3 divided by 32. So in this case also we get the same answer. So this is the acceleration of the particle at t is equal to 4 by 3 seconds. So if we say the option available to us is our option number D is the correct one. So you can say option D is correct. So we can solve the same question using any of the approaches, okay, either derivative approach or using the standard formula, which is our this one. So this we can say first method. In which we use the formula directly. So this completes the question. Thank you.